Hello everyone. Today we will going to study some practice questions from the chapter Organic Compounds Containing Oxygen. This is part 2. Let's start. Disclaimer. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Practice questions 11 to 20. Our first question. Sodium phenoxide reacts with carbon dioxide at 400 Kelvin temperature and 4 to 7 atmospheric pressure to give what? So basically, we have given a reaction under specific conditions like 400 Kelvin temperature and 4 to 7 atmospheric pressure. Sodium phenoxide reacts with CO2. We have to predict that what will be the product. Options are catechol, salicylaldehyde, sodium salicylate, or benzoic acid. You have some time to think about this question. After that, we will see the answer. Let's see. The correct answer for the given question is option C, that is sodium salicylate. We have this sodium phenoxide, which is benzene, over which at the para position we have ONA, O negative, Na positive. We react it with the carbon dioxide at the condition of 400 Kelvin temperature and 4 to 7 atmospheric pressure as given in the question. Now what we will get? The CO2 reacts with the benzene and the resonance happens like this negative charge will stabilize here. Okay, and then the active site will be at the ortho position. So the COO will attach at the ortho position and we will get our sodium salicylate, which is benzene. At the para position we have O negative Na positive, and at the ortho position we get COO negative Na positive. Yeah, so this is our final product which we will get after this reaction. So our correct answer is option C, that is sodium salicylate. Let's move on to our next question. Phenol on heating with CHCl3 and NaOH gives salicylaldehyde. The reaction is called. So again, we have given a reaction that phenol is heating with CHCl3 and NaOH and the product will be salicylaldehyde. We have to name the reaction. We have to find the name of the reaction. The reaction is called. This question has been into JEE Mains in online mode in 2013. Options are Reimer-Tiemann reaction, Claisen reaction, Kenny-Zaros reaction, or Hell-Volhard-Jelensky reaction. You have some time to think about this question. After that, we will see the answer. Okay, let's see. So the correct answer for the given question is option A, that is Reimer-Tiemann reaction. The reaction is known as Reimer-Tiemann reaction when phenol reacts with CHCl3 and NaOH. Okay, and we get the product as salicylaldehyde. Benzene at the para position hydroxyl group is attached, and at the ortho position we have aldehyde group. Plus 3 molecules of NaCl and 3 molecules of water is side product. Okay, so when phenol benzene at which we have OH at the para position plus CHCl3 plus NaOH is the reaction, and we get salicylaldehyde. The name reaction, this is a name reaction. The name reaction name is Reimer-Tiemann reaction. Okay, so our correct answer is option A, that is Reimer-Tiemann reaction. Okay, let's move on to our next question. Phenol is heated with a solution of mixture of KBr and KBrO3. So there is a mixture containing KBr and KBrO3, and we are heating phenol with the solution of this mixture. The major product obtained in the above reaction is. This question has been into AIEEE in 2011. Options are 2-bromophenol, 3-bromophenol, 4-bromophenol, or 2,4,6-tribromophenol. You have some time to think about this question. After that, we will see the answer. Let's see. So the correct answer for the given question is option D, that is 2,4,6-tribromophenol. Br2 is formed by a redox reaction. 5Br negative plus BrO3 negative plus 6H positive, giving us 3 molecules of Br2 and 3 molecules of H2. So Br2 we get by a redox reaction in which oxidation and reduction both are happening simultaneously. OH group, hydroxyl group, is the activating group. Okay. OH group is the activating group, and there is Se at ortho and para positions, giving yellowish white precipitate of 2,4,6-tribromophenol. So basically, in this reaction, the phenol is having OH group, right? So OH group is the activating group, and there is Se reaction, Se mechanism, substitution and elimination reaction at the ortho and the para positions, which is giving us yellowish white precipitate of 2,4,6-tribromophenol. So basically, when phenol reacting with the 3 molecules of Br2, which we have got from the redox reaction by KBr and KBrO3 reaction, what will happen? The ortho and para position get activated, and Se mechanism is consisting of 2 steps. In the first step, we have the carbon ion formation. It is the slowest step, and in the second step, we have the electrophile attack, and we get our ortho like 2,4,6-tribromophenol as a product after occupying the ortho and all the para positions by the bromine molecule, right? Bromine atom. And 3 molecules of HBr we get as a side product. So this is our reaction when phenol reacts with the KBr and KBrO3. So KBr and KBrO3 giving us Br2 by having a redox reaction, and then the 3 molecules of Br2 attacks on the phenol, and as the ortho and para positions are activating for the attacking of the electrophile, that is bromine, so they will attack they will attack at the positions of ortho and para, all the positions of ortho and para in the benzene, in the phenol, and get attached to it. Okay, and then we will get 2,4,6 tribromophenol as our main product, right? And three molecules of HBr as a side product. So thus the product is basically 2,4,6 tribromophenol, and thus we have our correct answer as option D. Okay, let's move on to our next question. Phenol is heated with phthalic anhydride in the presence of concentrated H2SO4. The product gives pink color with alkali. The product is. We have a given reaction, that phenol heating with phthalic anhydride in the presence of concentrated H2SO4, And we have also talked about the product. That product is alkali, giving the pink color. Okay, so we have to find out that what will be the product. Options are phenolphthalein, bakelite, salicylic acid, or fluorescein. You have some time to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option A, that is phenolphthalein. Phenol is heated with phthalic anhydride in the presence of concentrated H2SO4 to give phenolphthalein, which gives pink color with alkali, as our question is asking. So this is the molecule and this is the phenol. So phthalic anhydride, we reacted with the phenol, two molecules of phenol in the presence of concentrated H2SO4. We heat it, we reacted it, and we will get our final product as phenolphthalein. Okay, so this phthalic anhydrides gets combined with the two molecules of phenol given, and it will form the main product as the phenolphthalein. Okay, so as asked in the question that what will be the product, so the main product is, and the correct answer is option A, that is phenolphthalein. Moving on to our next question. The structure of the compound that gives a tribromo derivative on treatment with the bromine water is. So now we have asked about our reactant, that which structure or which reactant of compound, or you can say structure of compound or reactant that gives, which will give tribromo derivative when we treat it with the bromine water. So we have to find out that particular reactant which we use to react it with bromine water to obtain a tribromo derivative. Options are benzene ring having methyl and OH group at para and meta position. Benzene ring having CH2OH group as a side chain. Benzene ring having methyl and OH group at para and ortho position. Or benzene ring having methyl and OH group attached as a side chain at the opposite para positions. You have some time to think about this question. After that, we will see the correct answer. Let's see. The correct answer for the given question is option A, that is benzene ring having methyl and OH group at para and meta position respectively. Metacresol, due to phenoxide ion in H2O solvent, gives tribromo derivative at all the ortho and the para positions. This is a reaction that benzene ring having CH3 and OH at the para and meta positions reacts with the bromine water to give us the tribromo derivative. Okay, so as you can see that in the metacresol, one para position is occupied by the methyl and one meta position is occupied by the hydroxyl, right? And when you react it with the bromine water, so all the ortho and para position get activated and the electrophile bromine gets attacked to the benzene ring and gets attached with it at the ortho and para positions, right? So you can see we get our tribromo derivative as it is said in the question. And tribromo derivative means that at all the ortho and para positions we have bromine electrophile attached to the benzene ring. At the one meta position we have hydroxyl group, and at the one para position we have methyl group as in the reactant. Okay, while if you take another molecule of the same structure, like only the difference is that OH hydroxyl group will be at ortho position, then we will get a dibromo derivative because one of the ortho and para position is occupied by the hydroxyl group already in the reactant. Okay, so when you react it with the bromine water, only you can get dibromo derivative, right? Because one of the site at the of the ortho position is already occupied by the hydroxyl. That is why you have only left with the two sites. One is para and one is ortho, at which electrophile bromine can attack. So we only get dibromo derivative. But as in the question asked that we get the tribromo derivative. So only that will be possible when the hydroxyl group is attaching to the meta position, or meta position is occupied by one of the hydroxyl group. Okay, then we will get a tribromo derivative. So our reactant is metacresol, and thus our option A is the correct answer. Moving on to our next question. When benzene sulfonic acid and para-nitrophenol are treated with NaHCO3, the gases released respectively are. So when you treat benzene sulfonic acid with NaHCO3 and when you treat para-nitrophenol with the NaHCO3, which gases will be released respectively in both the cases? Options are SO2 and NO2, SO2 and NO, SO2 and CO2, or CO2 and CO2 in both the cases. You have some time to think about this question. After that, we will see the correct answer. Let's see. The correct answer for the given question is option D, that is CO2 and CO2. Benzene sulfonic acid and para-nitrophenol both are stronger acids than the H2CO3, okay, which is a combination of H2 and CO2. So they are capable to evolve CO2 when reacts with the NaHCO3. HCO3 plus H positive from the acid, giving us H2O and CO2 as a gas. So when you react SO3H, benzene sulfonic acid, plus NaHCO3 with the NaHCO3, so you will get a SO3Na at the place of SO3H and H2O and CO2 gas. Similarly, in the para-nitrophenol, when you react it with the NaHCO3, you will get O negative Na positive at the place of hydroxyl group, and rest of the structure is same, plus H2O plus CO2 gas. Okay, so in both the process you get CO2 gas evolve, right? The evolved gas is CO2 in both the cases when benzene sulfonic acid and para-nitrophenol reacts with the NaHCO3. And that is why we have our correct answer as option D, that is CO2 and CO2. Moving on to our next question. The reaction of phenol with benzoyl chloride to give phenyl benzoate is known as. Again, we have asked about the name of a reaction when phenol reacts with the benzoyl chloride and the product we get is phenyl benzoate. This question has been in JEE Mains in online mode in 2013. Options are Claisen reaction, Schotten-Baumann reaction, Remer-Tayman reaction, or Getterman-Koch reaction. You have some time to think about this question. After that, we will see the answer. Let's see. The correct answer for the given question is option B, that is Schotten-Baumann reaction. The reaction of phenol with benzoyl chloride to give phenyl benzoate as a product is known as Schotten-Baumann reaction. Phenol reacting with benzoyl chloride C6H5COCl and giving us phenyl benzoate. The H positive is replaced by the CO C6H5 negative positive, okay, and basically the phenol, the H positive will be released and we will get only the O negative, right? And from this benzoyl chloride we will get C6H5CO positive, Cl negative. So this C6H5CO positive will attack at the O negative and make a bond with the oxygen, and there is a bond between carbon and oxygen, and we get our final product as phenyl benzoate. And this is a name reaction, and the name of the reaction is Shorten-Bowman reaction, and thus we have our correct answer as option B. Moving on to our next question. Match the following and choose the correct options. So we have given two columns in the table. First column is having reactions, second column is having some processes or some products or some observations. So you have to match column 1 with the column 2 correctly. In the column 1, A is Colbase reaction, B is Reimer-Tiemann reaction, C is conversion of secondary alcohol to ketone, D is Williamson synthesis. In the column 2, first point conversion of phenol to orthohydroxy salicylic acid, second point conversion of phenol to salicylaldehyde, third point heated copper at 573 Kelvin, and fourth point reaction of alkyl halide with sodium alkoxide. Options are A1, B2, C3, D4, A1, B4, C3, D2, A4, B3, C2, D1, A3, B4, C1, D2. You have some time to think about this question. After that, we will see the answer. Let's see. The correct answer for the given question is option A, that is A1, B2, C3, and D4. So A is connected to 1, that is Colby reaction is connected to conversion of phenol to orthosalicylic acid. Because in the Colby's reaction, it involves the formation of salicylic acid from phenol and carbon dioxide. The B, that is Reimer-Tiemann reaction, is connected to the second point in the column 2, that is conversion of phenol to salicylaldehyde. Because Reimer-Tiemann reaction involves the orthoformylation of phenols using chloroform and a base, leading to the formation of salicylaldehyde. C, that is conversion of secondary alcohol to ketone, is connected to the third point, that is heated copper at 573 Kelvin. Because conversion of secondary alcohol to ketone can be achieved through oxidation reactions, often using copper as a catalyst. D, that is Williamson synthesis, is directly linked to the fourth point, that is reaction of alkyl halide with sodium alkoxide. So Williamson synthesis is a reaction used to form ethers from the alcohols. It typically involves the reaction of alkyl halide with a sodium alkoxide. So these are the correct links, and thus we have our correct answer as option A, that is A1, B2, C3, D4. Moving on to our next question. The major product in the following reaction. So we have given a reaction in which the reactant is CH2OH and OH is at para positions of the benzene ring plus HCl. We heat it. What will be the product? This question has been into JEE Mains in online mode in 2013. Options are that same reactant, but chlorine is attaching at the meta position, and the benzene ring having CH2OH and chlorine at para positions, or benzene ring having CH2Cl and Cl at para positions, or benzene ring having CH2Cl and OH at para positions. You have some time to think about this question. After that, we will see the answer. Let's see. The correct answer for the given question is option D. So this is our reactant. We reacted with HCl, heat it. We will get the major product as benzene ring having CH2Cl and OH at the para positions. So OH is same as in the reactant at the para position, and CH2OH at the para positions, it's converted to CH2Cl. We get we eliminate the OH hydroxyl group attached with the CH2, right? Only aliphatic hydroxyl Aliphatic hydroxyl means hydroxyl group attached to the aliphatic chain, that is CH2, is substituted by the chlorine. This is because in phenol, the CO bond in this case, like at the para position we have OH, right? So C and O bond is stabilized by resonance. That's why it will not break and it will not get eliminated by the Cl. It's not substituted. Only the hydroxyl group attached to the aliphatic chain gets substituted by the chlorine, and that's why we will get our final product as major product as benzene ring having CH2Cl and OH at the para positions. Thus, we have our correct answer as option D. Moving on to our next question. What is the structure of major product when phenol is treated with bromine water? This question has been in JEE Mains in online mode in 2030. Options are benzene ring having bromine at 3 ortho and para positions, and at one para position we have OH group, or benzene ring having double bond O at the para positions and having 3 bromine group at ortho and para positions, or benzene ring having OH and bromine at the opposite para positions, or benzene ring having bromine and OH group at the ortho and para positions. You have some time to think about this question. After that, we will see the answer. Let's see. The correct answer for the given question is option A, that is benzene ring having OH at the para position and bromine at ortho and para positions. So, when phenol reacts with bromine water, we get a substituted bromine substituted product, which is 2,4,6 tribromo-phenol. Okay, this is a popular reaction, or you can learn it also, that when phenol reacts with the bromine water, the ortho and para positions get activated, and the bromine will react at it and attach to the ortho and para position of the benzene ring. So we will get 2,4,6 tribromo-phenol as our major product. Okay. Thank you.